find the radius and interval of convergence for this power series. Okay, we have n to the n times x to the n. So this is in fact x minus 0 to the n. So the center is 0. Okay, and we know a power series always converges when x equals center. That means for x equals 0, this power series converges. But we want to find more than this. So for x not equal to 0, x not equal to center, let's find the following limit. Limit n goes to infinity of absolute an plus 1 over an, where an is this general term. Okay, this is an. So that is limit n goes to infinity of an plus 1. Okay, this is an plus 1. Just replace n by n plus 1. Okay, this is n plus 1 raised to n plus 1 times x raised to n plus 1 divided by an. An is n to the n xn. Okay, let's find this limit. Limit n goes to infinity. Let's simplify the top. Okay, what we can do here is x n plus 1 is same as x to the n times x to the 1. Then x and xn cancel. So let me write over here. Limit n goes to infinity of n plus 1 raised to n plus 1 is same as n plus 1 raised to n times n plus 1 raised to 1. Okay, and x raised to n plus 1 is x raised to n times x raised to 1 over n to the n times x to the n, and we can see x and cancel, and when we take the absolute value n plus 1 n plus 1 n, these are all positive numbers, so we don't need absolute value but for x though, and we can pull absolute x all the way outside because this limit for n goes to infinity. So we can write in this way: absolute x outside and limit of what is left, n plus 1 to the n times n plus 1 over n to the n. Okay, let's find this limit. Okay, when n goes to infinity, so little bit of problem, this will be infinity raised to infinity, this is also infinity raised to infinity times infinity. Okay, how to find this limit? Look at here, let's combine these two fractions in this way. X limit n goes to infinity to the power n to the power n. I want to write to the power n and n plus 1 over n plus 1 over n, and outside times n plus 1. Okay, which is same as absolute x times limit n goes to infinity of, let's look at here, we can split this fraction. N over n is 1 plus 1 over n to the n times n plus 1. In fact, if we just consider this part, we cannot, but if we just consider this part, 1 plus 1 over n quantity n, when n goes to infinity, this would be an e. Okay, just e, an irrational number about 2.7. But when n goes to infinity, this part is infinity, so whatever here, it will be infinity. So the whole thing is in fact infinity. This limit does not exist, so big it will be infinity. Okay, it's kind of waste of steps. We could have seen from here, n plus 1 to the n and n to the n, they increase about the same. Okay, but when n goes to infinity, this factor makes everything infinity, so this limit is infinity. Okay, that infinity, and this is never less than 1, so this power series converges only for x equals center, x equals 0. There are no x values. Okay, this is not equal to 1, so we cannot use the power series. Okay, so the given series, power series, converges for x equals center 0 only, and the radius of convergence, there is no radius is 0, and interval is just 0. Okay, in this number line, just for this 0 it converges.